In this video, I'm going to discuss about few interview questions normally asked on the ARIMA modeling, the time series ARIMA modeling. Um, One of the common questions people ask is, what are the steps involved in ARIMA model? Now, this is one interview questions which is a pretty general in the sense that um, most people use uh, their own way of modeling ARIMA, but there's some standard approach used by people in the industry. It may not exactly be the same what people are using in different industry, but some of the common steps, there will be variations of it, but some of the common steps used in the ARIMA modeling are as follows. So you start with plotting your data. So you do your exploratory data analysis pretty much like any other modeling exercise. What you learn from the exploratory data analysis of the time series data is that you'll get an overview of whether your data is having seasonality, or it's showing some sort of a non-stationarity. There is changing variance, changing mean, and so on. So the preliminary idea is found by just plotting the data before even going to some diagnostic statistics. Okay. Um, if the variance is changing, sometimes it can be stabilized. Okay. There are some transformations which are available, like the Box-Cox transformations, which is useful to stabilize the variance, and that really helps making sure that the variance is uniform across the series. Sometimes even with a Box-Cox transformation, it's not possible to stabilize it. So you have to do a deep dive into the data to make sure that if it is if there is issues with your variance, or it's changing over time, can you stabilize it by Box-Cox transformation or some other transformation? Then you check for stationarity. Check for stationarity of your data. If it is stationary, that's good. You can go ahead with the next steps of modeling. But if it is non-stationary, either you can you can test it the non-stationarity, or you can just do it by check it by plotting, or just use some statistical test to check for non-stationarity. If it is non-stationary, then you have to take the difference, right? So in one of the time series video on our channel, I have talked about how to do differencing and what exactly is differencing. So in the ARIMA model, the I stands for the differencing parameter. Okay. So when we talk about this P, D, and Q, so D is the number of differencing that you are doing in the ARIMA. Alright, then you check for the ACF, PACF, and find out the order of MA and um, the AR values. Okay, the MA terms and the AR terms. Okay, the order of MA and AR. And then once you're sure about how many number of differences are there, so you're sure about what the D term, it is 0, 1, or 2. Okay. If it is stationary, then of course it is going to be 0. If it is non-stationary, either it's going to 1, 2, or 3. So and then there will be certain AR and MA terms. So the next step would be to find out what is the optimal number of orders for AR, MA, and D. Okay. And that you can find out by using some standard matrices. Okay. So what you can the we'll talk more about it in one of the next questions. You can and that's based on the prediction accuracy and also some other means in which you can optimize it. But the idea here is that the D and Q value in ARIMA, right, should be in such a way that the model is giving high prediction or accurate prediction. It has high prediction ability or accurate it gives accurate predictions. All right, the next step is to check for the residuals. Okay, even if the model is able to provide good accuracy, how do we ensure that this is the optimum model? Okay, can it be made better? That you know by plotting the residuals. So the residuals should be white noise. That means the mean should be zero. The mean should be zero, and the standard deviation is one. So that's a standard deviation. It's constant standard deviation and constant mean, and zero mean in particular, for it to be white noise and zero autocorrelation. And why is it so? If it is not white noise, okay, if there is pattern in the residuals, there is pattern in the residuals and the residuals are correlated, then we are missing out on something. I mean, we are missing out on certain information in the model. So you need to go back and see if you can change the order of your ARIMA model and ensure that it can be made better. Okay, sometimes you may have to increase the number of differentiation. Okay, so you have tried for d equal to 1 and 2, so first difference, second difference, you might have to do higher differencing, like third difference, and so probably you might have to take, let's say you have taken AR1, check for AR2, AR3, and so on. Similarly for MA, check for higher order of MA and see for which model the error or residual terms are following white noise. Alright, so when you put it in diagrammatical form, these are the steps. You start with some data, you plot it, take stationarity. If it is not stationary, then take the difference. If it is stationary, then check for ACF, and then after taking difference, if it is not stationary, come down to checking CF and PACF, and then find the value of the AR term, ARP, and the MAQ. Okay, so find out the value of P and Q in the terms, and it's not necessary that you always have to have a AR or P term. Sometimes P and Q can take any value, any positive value. They both could be zero as well. Okay, and then you check for model fitness. You already have the value of D, the number of differences, and then once you have the value of P, Q, and D, check for model fitnesses. That you can do by checking the archaic information criteria, and the one which is having the least AIC value or the most parsimonious value is the one which is fitting your data very well. And then another diagnostic test that is a compulsory test in ARIMA modeling is the residual test. Once you have fine with the residual, that means residual should be white noise. If this is not white noise, then go back. You have to go back and then do a better fit of the model. If it fits or it passed through the diagnostic checks for white noise, then you are ready that the model is good, and then you can do your forecasting. These are the steps. The next question is, what are the ways to determine the order of ARIMA terms? Okay, the previous questions we talked a bit about it, but we didn't talk about it in detail. Okay, if you go through my video on the time series analysis theory or the theory about ARIMA model, both these videos are there in my channel. You can go through them. I have explained in detailed manner. I'll just do a brief recap of what I've explained there, and I'll just explain what are the ways in which you can determine the value of P, D, and Q. That means P is the number of AR terms required, Q is the number of MA terms, and the D is the differentiation. Okay, so we learned in the previous questions that the number of differentiation is entirely depends on how many times it has to be differentiated to make it stationary, how many difference it requires in order for the series to become stationary. Okay, so what it is a non-stationary term when you take the difference of it. Okay, let's say you are taking y minus yt, then if you plot it, it becomes, more stationary. You may have to do another or maybe second differentiation, and then it becomes more stationary. Okay, and that determines what should be the exact value of d, or the number of differences that one has to take. So the value of d is fine. Now the value of p and q you can get from the ACF and PACF, right? If you're not aware of what this ACF, PACF are, these are autocorrelation function and the partial autocorrelation function. So please go through my video on theory of time series analysis theory. You will it's explained properly. Okay, that you can do. Okay, however, these steps will not ensure that you have found out the correct order of ARIMA. Why so? Because you are taking a decision on p, the correct value of p, q and d on a standalone basis. I mean, you are not combining them together, or you are not combining them together and finding out what is the optimal p, q and d. Okay, so that means p and q are not determined based on how many differentiation or how many differencing is being done. Okay, and that's the problem. Okay, so jointly finding out what is the correct order is important, and that can be found out only by looking at the model fitness. Okay, so let's say to make it more simple, let's take an example. So you just found out a model which you think is ARIMA 111. Okay, so you found that there is only one difference required, and then one air term and one ME term. But and then maybe the error terms are also white noise. That means you can go ahead and finalize the ARIMA 111 to be your final model. But that's not the correct way of doing, because you can actually check whether how does ARIMA 212 behaves. Okay, sometimes you will see that the prediction accuracy, or the accuracy of prediction for ARIMA 211 is better than ARIMA 111. Now, from the standard way of finding out the order of ARIMA, we have found out the first one, but the second one is giving the better prediction. Okay, since they are very similar, if the residuals are fine with ARIMA 211, so that's the better model. Okay, that's the second step in which twisting the order of ARIMA. The first few orders you will always find out in the preliminary steps, but you have to do a bit of twisting, or fine tuning of the orders in the next step. The third one is parsimonious. Okay, so you can check at the AIC and SBIC values. The one which is the least is also good. Okay, that means the lesser number of terms in the ARIMA model, the better is the model. That is expected. Okay, so if there is equal accuracy like ARIMA 111 and ARIMA 211, both are giving exact accuracy, then ARIMA 111 is preferred over ARIMA 211 because it's more parsimonious. Parsimonious is nothing but simpler. Okay, so it's just a jargon used for simpler model, or model with lesser number of terms. Okay, the final question is, how do you validate the ARIMA model? Okay, you might have come across a number of videos on my channel where I've talked about model validations for multivariate models, like regression model, classification models. And the usual way of doing it is take, divide your data set into two types. Take, let's say, 60-70% of your data as training sample. Okay, and then 30% of your data, 20, 30 or 40% of your data as hold out sample or testing sample, right? And then you build a model on training sample, test it on the testing sample. If there is consistency in the model results, then it's a it's a good model. Okay, you build a model on a training and then test it on the testing sample. So that's the usual way of doing for um, multivariate models. How does it matter in the how does it uh, apply to time series forecasting? Remember one thing, for time series forecasting we take only one uh, variable, right? It's a univariate time series, right? So the only way in which you can divide the sample, because you have to take the latest observations, so that it cannot put it in the holdout sample. Okay, so one has to be very careful while finding out the in sample and out sample, okay, or the training sample and the testing sample. Let's say you want to do prediction for stock market and you have, let's say, data for the current period. That period has to be there in the uh, training sample. So the in sample and out sample, or the training and testing making sure that you have training data and then testing data will be slightly different for time series analysis. Okay, um, one thing people do, and I'm not sure to what extent that is theoretically correct, is that they take the full sample for the as the training data, and then they take smaller samples of it as the testing data from the training data, and then fit the model and check for the accuracy. Okay, um, that's also okay, and people use it. So that's one way of validating it, but that's not the it doesn't give um, I mean, one has to be a little more careful. That's exactly the point. The reason why I'm emphasizing a lot on this is because many times what happens is that since the only way you cannot choose random values from your time series data. For example, let me explain it properly. I think this is very important. Let's say we have data for last 10 periods, okay, from 1 to period 10. Okay, now you might wonder that, okay, maybe 6 periods I'll take in the training data and 4 periods I'll take in test data. That means, let's say you choose period 1 in the training, and then period 3 in the training, and then period 6 in the training. That you can't do. Remember, time series data has to be uniform. That means the interval between two data points in time series should be same throughout. Okay, that means you cannot take sample periods like that. Okay, and then that means you have to take the entire population in the training sample. Okay, however, for testing purpose you can take a resample, take smaller sample out of this training, and test your model if it is working fine. Or maybe you can just test it for a historical time period which is similar to the current time period. Okay, the trend may not be same, because in time series the pattern may not be same for two time period, but if they are same or similar to each other, you can test your model for the validation purpose, for just to check for the predicted values and the actual values. So that's one way of validating. And then the most important thing is the diagnosis of the residuals. Okay, the residuals in a good ARIMA model should be uh, should be white noise. Okay, should be white noise. Okay, with all the properties like mean, zeros, and whatever. There are also some statistical tests you can do just to see whether it follows white noise. So if that is there, then theoretically the model is sound. And when the model is theoretically good, uh, it is expected to, that's the best you can do about modeling. Of course, it might fail in future, Not all good theoretical models work well in the real-time scenario, but nothing can be done. Theoretically, when it's good, you can be sure of one thing, that you can be it at least meets the baseline prediction. Okay. And it might fail in certain scenarios or in certain specific scenario. Otherwise, in the baseline scenario, will well be captured in the theoretically good model. Another important to remember is that the ARIMA model or most univariate time series models are preferred for short-term forecast. Okay, for forecast for next few months. If you're intending to do forecast for longer period, univariate time series models are not very preferred. So you better go for multivariate regression model for forecasting. With maybe you can include a time series component in those models that's also capture the time series aspects. But mostly times regression models are only for short-term forecast, and that's also need to be kept in mind. Okay, so thanks for watching, and please subscribe to our channel, and also please go to our website, which is in the description. Thank you. Thanks for all your support.